let's see the system design for Uber. Now, before I jump on lecture and explain each component, so let's see the functional requirement and non-functional requirement of Uber system design. So let's focus on the functional component. See, whenever you open this app, that is Uber, what you are expecting, that is something we are going to see in the functional requirement. So when you open this app, we first, as a user, we need to see the gaps which are around you. So that becomes one of the important part, that we have to see all the gaps which are around our vicinity. Next, we check the ETA, price, pickup, and destination. These are the attributes which we need important to book any cab. We need to know what is the time that I'll reach that destination. We need to know what is the price and what is the destination spot exact where Uber is going to drop us. So all these things we need to check before we book the cab. So these becomes our functional requirement. These are the functional requirement. Next, very important functional requirement is booking the cab. So when I say booking the cab, that means whenever user clicks book the cab, at that time this functionality calls different types of services which we are going to look into it. And it's just not just a click and it books the cab. It's not like that. It will call payment service, it will call map service, location service to check like whether the driver is available or not. All this no, you just watching like all the cabs are around, it's different thing, and booking a cab is a different thing. So this is a very high priority functionality which we need to understand how to book the cab. Next, this is again not a high priority, but I would like to let you know that always do a location tracking, like a driver moving tracking, live updates. What are the live updates of the driver? Which location he has reached? If the trip is more, then live updates of the trip has to be updated in the trip service. So what should be the pricing according to it? So all this comes as a functional requirement. So we will be watching these 4 points, how to implement this in our system design. Then non-functional requirement comes like it can be a global, because app has to work everywhere, so we need geo distributed servers. Then low latency, yes, wherever there are nearby drivers and nearby location. Suppose a customer is nearby to some drivers, then definitely the cab booking should be very much easy. High availability and high consistency, so drivers should be highly available where there is a lot of customers. And high consistency depends upon the scenarios like payment service, transaction service, map service, where you need consistent service of that particular scenarios. Scalable, it should be highly scalable for both for the drivers as well as for the users. Now let's see what is the core idea. When I say core idea, meaning why this app was implemented. So there was some problem where there are customers which are present in one of the location which has latitude and longitude, and these customers need a very quick finding of nearby drivers, which was not possible because such app was not implemented. So Uber resolved this issue, and how it is resolved, let's get into deeper. So the problem was customers are having latitude and longitude, and we need to identify quickly the nearby drivers. So what was the solution? We divide the city into segments. When I say different segments, let me explain what does that mean. So suppose this is rough map, and we have these segments. Okay, so every city, every state is then divided into these kind of segments, and each segment becomes a box. You see, this is one of the box, this is one of the box. This box consists of latitude and longitude. So we'll have like a driver is present in this latitude and longitude, so we'll come to know, okay, this is the driver over here. And if a customer is present over here, okay, these are nearby latitude, longitude, so let's assign this driver to this particular customer, something that sort of an. So when I say coordinates, what exactly does it mean? So suppose this is a box which has a coordinates of 0 0 0 1 1 0 and 1 1, right? Then suppose there is a driver over here. The coordinate of this is 0.4 and 0.5, which is between this box, right? So we come to know that this driver is between this latitude and longitude, between these coordinates, and they are near to the users wherever, because the user coordinates will also be 0.7, 0.8, which will be again inside this box. So we can assign this driver to this particular customer. So this was the problem was resolved by map segmentation. Now who is doing this map segmentation? In Uber, we have where we have the map service, and map service resolves these issues. So map service does this map segmentation, and this is very important functionality in the Uber to resolve all the issues. Like to see the cab around you, we need to see this segmentation. To book a cab around you, drivers of that segmentation, we need to check it. To know the ETA and a price of pickup and destination, right? So estimated time or a price depends upon that segmentation, like is that driver a premium driver or whatever is the priority of the driver, depends on everything on this. So map service plays very much important role, because a pickup and drop, suppose the pickup is from here and the destination is here, so we'll also check the coordinates of this box along with this box to check the estimated time. So this becomes a very important functionality. Now let's see the high architecture diagram, and let me draw the map service as well. Here is our map service. So basically, this is a customer app. So this is a customer app. This is a user service. Now, basically, what is user service all about? It is consisting of different information of the user. Suppose user want to update the profile name or any payment details or anything on the app, then it will call user service to update this, update the data. Now let's take a scenario one. Let's get into the scenario and start working out slowly so that we understand this architecture exactly. So the first scenario is, how can customer app see the caps around itself, right? So that was our first functionality. So when the customer opens an app, right, app sends a request to the cab request service, with the help of the WebSocket. With the help of a WebSocket, app sends a request to the cab service, like send me the driver which are near to the segment, near to this segment, whatever wherever the customer is located. So cab request service sends that request to map service, asking a map service to give the segmentation of a customer as well as check the segmentation of the drivers, right? Now, uh, once that is done, so once the segmentation, we understand the segmentation, once that is done, this map service then checks with the location service, and location service return nearby driver. So basically location service have that segmentation driver IDs, and the last known location is present in the location service. And how is it done? By calling the Cassandra. Cassandra has all the data which is present under them, to get all the information of that particular driver with the driver ID and the location which was last known. Also we have a Redis. If any questions we need to ask, like same driver we are asking 100 times, right, then we can get that information from the Redis. And this response is then again given to the CAP request service, which is then given back to that WebSocket, and through WebSocket it is given to the customer app. So our first scenario to see the caps in that vicinity, that segment is resolved. So this is scenario number one. Now the scenario 2 is ETA and approximate time. The customer always want to see what is the estimated time and what is the approximate price. So now the same request is sent to the cab request. I need to know the destination price, fare price, and estimated time. So cab request service again sends a request to map service. When it sends a request to map service, now it routes the pickup and drop. What it does, the first thing is it routes the pickup and drop. So pickup and drop, it routes and it checks the estimated time along with the segmentation. Next service, that is the pick drop, it calculates the ETA of that particular segmentation. And second thing is price service. There is something as a price service which check the base fare price of that particular segmentation. So basically, map service first does this work. It calculates the ETA of pickup and drop, and then it calls a price service to check the fare price. And both of this is again given back to cab request service, which is again given to the customer app via WebSocket. So our second scenario is complete. This is typically how the things work, and you can also have here the Redis. You can ask your interviewer whether we need to cache the price of that particular destination. If that destination is very much repeated, then we can cache the price as well of that particular destination. Now let's see the third scenario. Third scenario is very important, that is booking the cab. Because once you know it is near your vicinity, once you know the estimated price, once you know the pickup and drop estimated time, then for sure customer will uh, click on book the cab. So when book the cab is clicked, cab request will send first request to cab finder, get the customer segments from map service, and then queries the location service. So what cab request service will do, it will first it will first call the cab finder. And now cab finder, basically it finds the cab, right? So what cab finder will do, it will get all the customer segmentation from the map service. So it will call the map service, it will get the customer segmentation. Then once that is given, it will call the location service to check the driver along with its driver ID for that segment, is it available or not. Check that, location service will again call Redis. If it is not in Redis, then it will take it from Cassandra, right? So this is the first step. It is checking whether the driver is available in that particular vicinity or not. Once this is done, once we get the driver, then the location service will also call driver priority. What is this driver priority engine? Basically, there are premium customers, there are average customers, there are standard customers. So those who are premium, we find the best drivers which has a highest rating, right? So location service will check, okay, this is a premium, so we need highest rating driver, and it will call driver priority engine to check that things. So now we got a perfect driver which is based off that particular segment, which is based according to the customer preferences, which is based according to that particular price. Now what happens, this information is given to the cab finder, and now the cab finder will again call WebSocket manager, because now a cab finder wants to know, like, the driver is suppose D2, which is given by the location service. Then this D2, how to connect D2? So WebSocket manager will say, okay, D2 can be connected with the WebSocket handler, and this WebSocket handler is then connected to D2. So the cab finder will go to WebSocket handler 2 and get to D2, that is to the driver, see whether the driver accept the request or not. Now, once the request is accepted or fail, let's see the failure scenario. It says, okay, it is failed. It rejects, the driver rejects the trip. Then it get again route to the cab finder. Again, the cab finder will check with map service to check a next driver availability. Suppose let's see the scenario, a positive scenario where driver accepts the request. Then what happens? Once the driver accepts the request, it let the cap finder know that driver has accepted. And how it is letting cap finder know? Via via WebSocket handler 2. Then this is again given the request to cap finder that driver has accepted. Once this is done, the cap finder will call trip service. Here there is something called as a service, and it will update the status of trip service that this has been accepted. And this trip service will then call trip MySQL, insert a record that this is a new trip and it has been accepted. And this will be saved back again to Cassandra. So from SQL, it is going to Cassandra via trip archive. That is why we are using trip archive. So this is the positive flow. I hope you have understood how to book the cab. Like once it is accepted, it will go into trip service and it will store that particular trip. So I hope this is a big scenario, and this is the main gist of the Uber system design. So this was the third scenario which I spoke on. Next scenario, that is the fourth scenario. What happens if driver location, if the driver, when driver comes online? So the scenario which we saw was according to the customers, right? What happens when customer open an app? What happens when customer book a cab? What is the let's check on opposite side. What happens when driver comes online, right? So when the driver is online, what is the scenario all about? That we will see now. So when driver is online, first thing is it will ping it to location service that I'm online, and it will ping every 5 seconds that I'm at this particular location. So that location service will ask the map service the segmentation, and it will check, okay, at this segment this driver is located, and this will be saved in Cassandra as well as in Redis app. So anytime whenever a customer is coming and a cab finder is asking a location service, like find me a driver at this particular segment, it can easily give from Redis or it can give it Cassandra. This is the way it happens. So this is a scenario when driver comes online, it will ping to that location service. So basically once it is online, it will call this location service. Now let's see what is live tracking scenario number 5. What happens, what is this live track? So as I mentioned, when driver is online, basically it pings the location every 5 seconds, right? So because it is pinging that location every 5 seconds, we are getting the updates of live location. We are getting the updates of the live location. So cab request service will thus send a request to the location service that what is the live location of this particular driver, and thus it sends, location service will check and send the location that okay, this is the location of this particular driver. This location service is then giving the same results to trip service, saying this is the live update, so you please calculate the final amount and give it to the user. So live tracking will help give the payment as well. Now let's see how the payment is made. Trip completion payment. Okay, just this has become a lot of um, jiggling here, so I'll just rub little bit so that there are no confusions again. Okay, so when the trip service is completed, what happens? Like when the trip is completed, right? This trip service is completed. Now we need to pay. So the trip is being updated in the trip service is completed. Thus it updates the Cassandra. It also updates the Redis cache, and then it calls Kafka. Now what happens inside the Kafka? So Kafka basically have lot of I should say, let me just so that it's not okay. So, so the Kafka, if you see Kafka, basically it has a lot of. So what happens in Kafka? Kafka calls the payment service. Payment service then calls the trip service to check the status whether it is completed. Once that is done, it will calculate the final fare, and then answer it to the driver that $50 is the fare, and the same thing final answer is given to the user app service that $50 is the fare. That is how the payment service works. And suppose now this is the scenario number 6 which we completed, like how payment service works. Now the seventh scenario, if there are no drivers found, right? If there are no drivers, there are zero drivers which are found in that particular segment, then what happens in that case? When there are no drivers, right, call something called as Spark streaming services. What are these streaming services? It will first check the demand hotspot and high cancellation zones, like the driver is canceling lot of times. Many drivers are canceling. Then it generates the heat map. So this heat map is nothing but a graph which will generate for analytics so that we can understand that next time onwards we need more drivers at that particular segment. So we generate a heat map to understand, okay, there are no drivers here, but the traffic of customers are more. So this is one way of an ML model which works over here to check how can we increase more amount of drivers in this particular location. Next scenario, that is the eighth scenario, related to fraud. So what happens fraud scenario? For example, a driver and customer are same, like a driver opening app as a customer and driver himself opening an app as a driver. So that becomes a fraud scenario, and this can be done because of incentives from the company. So he's just checking, he's just finding some location, destination location, and he himself is going over there and using that app, right? So that is called as fraud service, and fraud service calls a fraud engine where it checks basically repeated, if those are same duplicate users, if there are any abnormal routes, and if there are any incentive abuse patterns. That all three things are checked in the fraud engine. Next, last is related to history. Suppose a user needs to know what is my trip history. Suppose a customer app or a user needs to know what is my trip history, then directly it calls trip MySQL via trip service. Trip service is called, service calls MySQL, and also it calls Cassandra. If the data is in Cassandra, fetch the data and give it to the customer. So this is all functional scenarios which I spoke. These nine are the functional scenarios which I spoke. Now, what about non-functional? If you need this global, then definitely we need to have so non-functional is global. So we need to deploy the stack per geographical servers and route the users to the. If we need low latency, definitely map service is an important role because it checks the segmentation and accordingly it gives the near. So low latency will be resolved there. High availability, again, WebSocket manager should always give the driver immediately, should always checks which WebSocket handler is active right now. So the driver is active, right? So because of which we can get a high availability of those drivers. High consistency depends upon payment service. It should be consistent for every user and it should work same as it is. Maybe it is a fraud scenario, maybe it's a no driver scenario. So these should work very consistent. And this should be scalable geographically, it should be scalable at different regions, it should be scalable. And there should be Kafka for live updates, it should give the live tracking as well. So this is all about questions, drop it and let me know anything. Thank you.